Learning objectives. In this chapter, the users would learn the following aspects of buses and ports. Study of various bus standards: ISA, EISA, VL, PCI, PCM, CRA, AGP, etc. Ports like PS2, COM, LPT, USB, IRDA, etc. Memory types: SIMM, DIMM, etc. Introduction. A bus is a system that moves the data from one source to another. The implementation of bus in early computing was achieved by system bus. There are various types of buses which are used in the desktop computers. Some of them are EISA, ISA, PCI, VL bus, AGP. Buses. A set of physical connections which can be shared by multiple hardware components in order to communicate with one another. Purpose of bus is to reduce the number of pathways needed for the communication and carry all communications over a single data. This includes all hardware, software components, and also protocols. Information travels on buses as series of electric pulses. Each pulse represents 1 bit or 0 bit. The size and width of the bus varies according to the number of bits it carries in parallel. The speed and capacity of the bus depends on the pulse and how fast it moves the data in a second. Some buses move 2 steps during each cycle. It is known as double pumping the bus. There are 2 types of buses. First one is internal bus and the other is external bus. The internal bus moves the data, address, instruction, and other information between the register and other internal components inside the processor. The external bus is present outside the processor and moves the data, address, instructions, and other information between the register components and other internal components through the processor. Buses can be parallel buses in which the data travels in parallel, or a serial bus in which the data travels in a bit serial form. Characteristics of buses. A bus is characterized by amount of information that can be transmitted at once. This amount is expressed in bits, which corresponds to a number of lines over which the data is sent. The bus speed is defined by its frequency, number of data packets received or sent per second. Each time data is sent or received is called a cycle. In this way, it is possible to find the maximum transfer speed of the bus. The amount of data which is transferred per unit time is calculated by multiplying its width by its frequency. Features of buses. Each and every bus is composed of 2 important features. First one is data bus and the other is address bus. The data bus is most referred because these are the lines that carry the data being transferred. The address bus is a set of lines that carry the information from the memory to the bus or from the bus to the memory. Since the bus is the data channel through which the information flows, if the bus is wider, more information can flow along the path. With the help of these features, the bus bandwidth explains the amount of information that can be theoretically transferred on the bus in the given time. What is a port? A port is an application-specific or process-specific software construct serving as a communications endpoint in a computer's host operating system. It is associated with an IP address of the host as well as a type of protocol used for communication. Purpose of ports. The purpose of ports is to uniquely identify different applications or processes running on a single computer, thereby enabling them to share a single physical connection to a packet-switched network like the Internet. The protocols that primarily use ports are the transport layer protocols, such as the Transmission Control Protocol (TCP) and the User Datagram Protocol (UDP) of the Internet Protocol Suite. A port is identified for each address and protocol by a 16-bit number, commonly known as a port number. The port number added to a computer's IP address completes the destination address for a communication session. Among thousands of enumerated ports, about 250 well-known ports are reversed by convention to identify specific service types on a host. In the client-server model of application architecture, ports are used to provide a multiplexing service on each server-side port number that network clients connect to service initiation, after which communication can be re-established on other connection-specific port numbers. Features of ports. The ports have specified and recognized shapes. Some will be round, some are trapezoid, and some are rectangular. They also have determined sizes that are rather small, running, for example, from the size of a penny to the size of an electric plug. Some computer ports have a special well-known symbol that identifies it, like USB, FireWire, and other computer ports. Often, computer manufacturers provide easily identifiable symbols, such as a representation of a printer to identify an LPT port or a keyboard or a mouse for a PS2 port. Normally, the symbol is present right next to the place where the port is located, usually in the back of the computer. You can also find the symbols in manuals or in peripherals boxes. There are two types of ports, pin type and hole type. Serial and parallel ports refer to the way the port communicates the data that is being transferred. Every port can work with specific peripherals. Some of them can work with almost anyone, and some work only with one or two. Example is COM ports. Types of ports. There are various types of ports, namely Digital Visual Interface, Display Port, eSATA port, Ethernet, IEEE 1394 interface. Digital Visual Interface. Digital Visual Interface is a type of digital computer video connector which was designed by a digital display working group in April 1999, and it is present till today. It is hot pluggable with 27 pins. DisplayPort. DisplayPort is a type of audio or video connector designed by VESA in May 2006 and produced from 2008 till the present time. It has 20 pins for external connectors on desktops, notebooks, graphic cards, monitors, etc., and 20 or 30 pins for internal connections between graphics engines and built-in flat panels. eSATA port. eSATA port is a power port which was created in 2008. Ethernet. Ethernet is a family of computer networking technologies for local area networks, LANs. IEEE 1394 interface. IEEE 1394 interface, FireWire, is a serial type port which is designed by Apple Incorporated in 1994 with high-speed communications and isochronous real-time data transfer. The other types are parallel port, PS2 connector, serial port, USB port, VGA connector, SCSI, HDMI, audio port. PS2 connector. It is a PlayStation 2 connector and a 6-pin mini DIN connector used for connecting some keyboards and mice to a PC-compatible computer system. The PS2 mouse replaced the older DE9 RS232 serial mouse connector, while PS2 keyboard connector replaced the larger 5-pin 180 DIN connector used in the IBM design. The PS2 designs on keyboard and mouse interfaces are electrically similar and employ the same communication protocol. However, a given system keyboard and mouse port may not be interchangeable since the two devices use a different set of commands. Component Object Model, COM. COM is known as Component Object Model, which is a binary interface standard for software components introduced by Microsoft in 1933. It is used to enable the inter-process communication and dynamic object creation in a large range of programming languages. COM is the basis for several other Microsoft technologies and frameworks, including OLE, OLE Automation, ActiveX, COM+, DCOM, the Windows Shell, DirectX, and Windows Runtime. USB IRDA. USB adapter for wireless communication uses infrared interface. Some IRDA adapters support all current Windows to Windows 8, which is 64-bit. It delivers a cost-effective solution for file transfers between a USB capable of desktop or laptop. It is compatible with Windows 98 or 98 SE or Windows 2000 ME XP Vista, which is 32-bit. The hardware regulatory approvals are FCC, CE, and VCCI with IRDA version 1.3 industry standards. In addition, MIR, SIR, and USB are of version 1.1. The chipset used in USB is TANIC S110. There are two types of connectors, namely 1. IRDA, infrared SIR/FIR, and 1. USB-A 4-pin. The SIR transfers the data slowly, and its rate is up to 115 kilobytes per second. The requirement is a system with USB port. The USB port has an accessory USB 2.0 active extension cable, which is of 6 feet length. It has good reliability. Bus standards. The various types of bus standards are ISA, MCA, EISA, NU bus, VL bus, PCI, DIB, SECC, AGP, and DRD RAM. ISA, Industrial Standard Architecture, is a bus system for IBM PCs and PC clones. MCA, Microchannel Architecture, is a 32-bit bus. It was introduced in 1987 by IBM with a PS2 computer that is used in Intel processor. EISA, Extended Industry Standard Architecture, is a 32-bit bus running at 8.3 MHz and was created by Clone Industry in response to MCA bus. NU bus. NU bus is a 32-bit bus created by Texas Instruments, which is used in Macintosh 2 and other 680X0 based Macintoshes. It supports plug and play. VL bus. It is created for the Intel processor. The VL bus requires the use of manually set jumper switches. PCI. It automatically checks data transfer for error, which is created by Intel as 32-bit version. It uses a burst mode, which increases bus efficiency by sending several sets of data to one address. DIB. It is created by Intel, which increases the performance of the front side L2 cache. SECC. SECC was created for high-speed backside L2 cache. AGP. It increases the performance of the PC by separating video data from the rest of the data on the PC input or output buses. DRD RAM. It is memory buses which increase the speed of the connections between the processor and memory. Industry Standard Architecture ISA. The computer accepts only the machine language, which is the easy readable form of a computer. How is the ISA used in computation? ISA is the abstract image of a computer system that is seen by a machine language or assembly language programmer. It is a computer bus standard for IBM PC compatible computers, which was introduced with the IBM personal computer to support its Intel 8088 microprocessor. The 8-bit external bus is extended to 16 bits for the IBM personal computer or Intel processor. For general desktop use, it has been supplanted by later buses such as IBM Microchannels, VESA Local Bus, conventional PCI, and PCI Express. ISA is a derivative of AT bus structure, which is still used in PC 104 bus and internally within the input or output chips. Extended Industry Standard Architecture. EISA is a bus standard for the IBM PC compatible computers. It was announced in September 1988 by a consortium of PC clone vendors. It uses its proprietary microchannel architecture in its PS2 series. It can accept older XT and ISA boards in which the lines and slots for EISA are a superset of ISA. It is much favored by manufacturers due to some machines supporting it. EISA is more expensive to implement, so it never became popular in the desktop PCs. EISA cards are produced as network cards, which are available on some non-IBM compatible machines. Examples are Alpha Server, HP 9000D, SGI Indigo 2, and MIPS Magnum. Since there was a strong need for bus speed in desktop computers, so VESA, Local Bus, VLB, and later PCI were invented to replace the EISA. It is further extended for use with 32-bit processor. VESA Local Bus, VL Bus. The VESA Local Bus was mostly used in personal computers. VESA means Video Electronics Standard Association. It is a local bus which works along with the ISA bus. It also acts as a high-speed conduit for memory-mapped input or output and DMA, while the ISA bus handles interrupts and port-mapped input or output. VESA Consortium was formed in 1992 for faster graphic access in the IBM system. It has greater graphics card performance, and devices could also benefit from the VLB standards. The VESA Local Bus was designed as a stopgap solution to the problem of the ISA buses, which were with limited standards bandwidth. It relied heavily on the Intel 80486 CPU's memory bus design. Peripheral Component Interconnect PCI. The conventional PCI is shortened as PCI, which is a local computer bus used for attaching hardware devices in a computer. PCI is initialized and it is a part of the local bus. The PCI bus supports the functions found on a processor bus, but in a standardized format that is independent of any particular processor's native bus. The attachment devices can take either the form of integrated circuits fitted on the motherboard itself or an expansion card that fits into a slot. It was first implemented in IBM PC compatibles when it displaced the combination of several slow ISA slots and one fast VESA local bus slot as a bus configuration. It has subsequently been adopted for other computer types. Typical PCI cards used in PCs include network cards, sound cards, TV tuner cards, and disk controllers. The first version of conventional PCI found in the consumer desktop computer was a 32-bit bus using 33 MHz bus clock and 5-volt signaling. PCI 1.0 standard was provided for a 64-bit variant. Personal Computer Memory Card International Association, PCMCIA. PCMCIA refers to Personal Computer Memory Card International Association. The PCMCIA specification can be seen as a superset of ATA. The standard for PCMCIA hard disk interfaces includes PCMCIA flash drives, which allows mutual configuration of the port and drive in an ATA mode. As a de facto extension, most PCMCIA flash devices additionally allow for a simple ATA mode that is enabled by pulling a single pin low so that PCMCIA hardware and firmware are rendered unnecessary as an ATA drive is connected to an ATA port. ATA adapter is simple and inexpensive but is not guaranteed to work with any and every standard PCMCIA flash drive. Further, such adapters cannot be used as generic. PCMCIA ports or the PCMCIA interfaces are much more complex than ATA. The slots are of 3 sizes and types. All these 3 have the same rectangular size but different widths. Accelerated Graphics Port, AGP. The Accelerated Graphics Port, AGP, is a high-speed point-to-point channel for attaching a video card to a computer's motherboard, primarily to assist in the acceleration of 3D computer graphics. Originally, it was designed as a successor to PCI-type connections. The advantages of AGP is that it provides a dedicated pathway between the slot and the processor rather than sharing the PCI bus. In addition, to load a texture, PCI graphics card must copy it from the system's RAM into the card's video memory, whereas an AGP card is capable of reading textures directly from system RAM using the graphics address remapping table, which assigns main memory as needed for texture storage, allowing graphics card to access them directly. AGP version 3.5 is the only one publicly mentioned by Microsoft. Extra registers marked under the earlier AGP 3.0 included PCISTS, CAPDTR, NCAPID, AGP-STAT, AGP-CMD, NISTAT, and NICMD. Official extensions are AGP Pro and 64-bit AGP. Unofficial versions are Ultra AGP, AGP Express, AGI, AGX, XGP, and AGR. SIMM type memory. SIMM, or Single Inline Memory Module, is a type of memory module containing random access memory used in computers from the early 1980s to the late 1990s. It's different from the Dual Inline Memory Module, DIMM, the most predominant form of memory module. SIMMs were standardized under JEDEC JESD 21C standard. SIMMs were invented in 1983 and patented to become the basic memory module. The original memory modules were built upon ceramic and had pins. Later the pins were removed and the modules were built on standard PCB material. The variant of SIMMs have 30 pins and provide 8 bits of data. They were used in 80, 286, 386, 486, Macintosh Plus, Macintosh 2, Quadra, Atari STE, and Wang VS system. The earliest SIMM sockets were conventional push-type sockets. These were soon replaced by ZIF sockets, in which the SIMM was inserted at an angle and then tilted into an upright position. To remove one, the 2 metal or plastic clips at each end must be pulled to the side, then the SIMM must be tilted back and pulled out. The earliest sockets used plastic retainer clips which were found to break, so steel clips replace them. Some SIMMs support presence detects PD. Connections are made to some of the pins that encode the capacity and speed of the SIMM so that the compatible equipment can detect the properties of the SIMM. PD SIMMs can also be used in equipment which does not support PD. In that case, the information is ignored. Standard SIMMs can easily be converted to support PD by fitting jumpers if the SIMMs has solder pad to do so, or by soldering wires. DIMM type memory. DIMM or Dual Inline Memory Module comprises a series of dynamic random access memory integrated circuits. These modules are mounted on a printed circuit board and are designed for use in personal computers, workstations, and servers. DIMMs began to replace SIMMs as a predominant type of memory module as Intel P5-based Pentium processors began to gain market share. DIMMs have separate electrical contacts on each side of the module. It has 64-bit data pathway. Since Intel Pentium, many processors have 64-bit bus width, requiring SIMMs installed in matched pairs in order to populate the data bus. The processors would then access the two SIMMs in parallel. DIMMs were introduced to eliminate this practice. Several form factors are commonly used in DIMMs. Single data rate SDR, SDRAM DIMMs commonly came in two main heights, 1.7-inch and 1.5-inch. When 1U rack mount servers started becoming popular, these form factor register DIMMs had to plug into angled DIMM sockets to fit in the 1.75-inch high box. To alleviate this issue, the next standards of DDR DIMMs were created with a low-profile LP height of around 1.2 inches. These fit into vertical DIMM sockets for a 1U platform. Conclusion. In this chapter, the users have covered the following aspects of buses and ports. Study of various bus standards, ISA, EISA, VL, PCI, PCM, CRA, AGP, etc. Ports like PS2, COM, LPT, USB, IRDA, etc. Memory types, SIMM, DIMM, etc.